All right, so welcome to Track 1. This is researching Android device security with the help of a Droid army. I'm Josh Drake. I want to thank everyone that's come out to the show, and I want to thank the organizers for putting this event together. I think it's an amazing event. Adrian said last night at the community event that some people have given feedback like this is a really unique conference, and I think I was one of those people that told him that. It's like, it really is a unique event where I really like the layout, the way the tracks are separated and stuff. You look at Black Hat and they've got like just a ridiculous amount of tracks, and there's really not any sort of organization, any logical division of why there's so many tracks and what each track is for. But this is, I think, a lot better way it's designed. So anyway, without further ado, let's get into it here. All right, so here's a little agenda, what we're going to go through, just a little quick introduction of why I did this research and why I did this stuff, and so then talk about how it was the thing I built, how I built the Droid army, how I put it together. Talk about like what kind of stuff is behind the scenes, the software there, what you'll do with it, what you can do with something like this if you build one yourself. And then there's some demos here and there. There's a little one in the beginning and then a few more at the end. We'll conclude and then do a Q&A. So who, why, and what, right? So first of all, I'm Josh Drake. For those of you who don't know me, I go by JDuck on the internet. And I've done vulnerability research for many years. It was a hobby before it was a profession, and it started with BBSs way back in the day, and then it's progressed all the way to mobile phones today. So affiliations, me and 5 other guys put together this awesome book. If you don't have one, we're going to give away one at the end. And there's also a couple for raffle, I believe, at the end of the conference. So one at the end of the talk and then a couple at the end of the conference. So I'm currently the Director of Research Science at Occupant Labs. I'm one of the Directors of Research Science. There's a few of us. And I'm also the founder of the DroidSec Research Group. So while I was writing, actually before I even started writing this book, I founded the channel on IRC, the DroidSec channel, just to kind of bring people together. And I thought there had to have been other people out there doing Android security research, and so I put that together to make sure that I could get everybody in the same place so we could talk and share what we're working on. Before that, I worked at Rapid7 Metasploit. A lot of you might know me from that. I wrote hundreds of exploits for them. Not all of them entirely written by me, but still, lots of commits. I think I've finally been surpassed by Juan Vasquez, who's doing amazing work there now. But before that, it was VeriSign iDefense Labs, where I worked on their VCP, which is the Vulnerability Contributor Program, where we purchase vulnerability intelligence from independent researchers. So a lot of stuff. Sorry for taking so long on that slide. There's too much stuff on there. So the motivation for this talk is Android is a really unique ecosystem, I think, as far as operating systems go, because of what people call fragmentation, right? And this is kind of a dirty word if you're working at Google or something like that. They really hate this problem. They hate it when people use this word. And I think really this word is, it's probably a great word to use, but it also, there's different kinds of fragmentation in Android. It's not just one type of fragmentation, right? Like there's fragmentation within screen sizes, there's fragmentation within what's the hardware inside of the device, there's fragmentation with what's the software inside of the device. There's basically fragmentation throughout it, so if you can get more specific. And my focus really on, for the purposes of this research, was to try to solve the problem of the software fragmentation. As a vulnerability researcher and security researcher, like I'm always looking into the software, trying to find vulnerabilities or look for attack surfaces and things like that. So that's the fragmentation I talk about. So Dino actually said this a couple weeks ago. I thought it was a good quote. He said, fragmentation, I don't know, I like diversity. And it shows, his statement shows, looking at the same thing from a defensive angle. While the fragmentation can be seen as a problem because it's a challenge for research, it also is a good thing for defense, because all the phones being different means that a guy who finds a vulnerability may or may not be able to leverage that vulnerability against the entire Android ecosystem, and maybe only a small subset. We'll go into a little bit more about fragmentation. So I mentioned the hardware. The sort of canonical example of that is the Samsung Galaxy S3 or any sort of Samsung phone. Like they'll release something called the S3, but there's actually at least 2, probably 3, maybe 4 different hardware revisions that are inside of that model. They've got different radios, obviously, but some of them are completely different. Like the S3 for Sprint in the US runs a Qualcomm system on chip, but the S3 for Europe runs an Exynos chip. So it's completely different on the inside, even down to the actual processor itself. But also in code changes, compilation settings, lots of things. I'm sorry. It's blowing on the microphone. So development is also scattered. I mentioned that the software being fragmented, and that's because of the development process that goes into building an individual Android device. It starts with Google creating the core AOSP code, which is public and open source. You can contribute to it like a regular open source project if you choose. They sort of feed from the top, and then on the side you've got you've got the system on chip manufacturers, right? And they're building what's called a BSP, which is a board services platform. That's what that stands for, and that's kind of like their I can't think of the term right now, but it's kind of like, hey, it's like their reference design, if you will. That's the term. So it's kind of like their reference platform. They're like showing you, hey, look, this chip will work with Android. This is how we did it, and that's important, especially with all of the differences in hardware. They've got to do changes for their particular GPU, or for maybe working around weird quirks in their processor that they already produced billions of or something. So there's lots of things like that. And so those two guys, and then after that you've got the OEM, the original equipment manufacturer. Those guys are also making a bunch of changes, right? So they're optimizing, they're making it look pretty. You've got the Samsung TouchWiz UI, you've got like the HTC Sense UI. They've got these different UIs, and those all require a lot of changes to the core code base. So these all add together to make devices really unique. So that helps to solve the problem. So here's an effect of it, right? This is PuppyKitten is one of the Qualcomm security research team guys. He works on product security there. And he mentioned at one point, hey, we fixed this new bug. Here's the advisory. And Cedric replies and he says, that's a nice advisory. Which phones are vulnerable? And they're like, we have no idea, because they don't have all the phones, so they don't know. And really, they're so far upstream that phones are not something that is their focus, right? Their focus is creating that BSP and making sure that the BSP is secure. So they don't know who all is using the BSP. They could tell you maybe a list of manufacturers, but they couldn't tell you which all phones that those manufacturers used it in. And so this is another good reason to build sort of a Droid army to do that. Also, in vulnerability research and exploit development, you'll find that some bugs are only present or only exploitable on a certain subset. A compilation change that the OEM might have made, like say they added some optimization or they enabled a little flag here or there, that can really make a lot of changes to the point where sometimes things just absolutely aren't exploitable at all, or not even present. I don't have a great example of it right offhand, but I've definitely run into this a few times. So the end effect is that both research and test time is multiplied whenever you're trying to do anything for an Android device, or especially if you're more broadly focused on the entire Android ecosystem. You've got to replicate all of the work you've done on each device, because the OEM could have introduced code that changed it. The BSP could have changes that introduce vulnerabilities. Basically, every change is a potential vulnerability. So the fact that each device has so many changes that are even unique to that device mean that you have to keep doing it. So small differences are almost guaranteed. And with this, I've found that to do research on a more broad scale, you have to really have a physical device. And that's because using an emulator is okay, but the emulators are very slow. But not only that, but the emulators, they don't have all of the hardware that's present in a device. They don't have like a gyro in the emulator. Nobody's going to be shaking their VM around, I don't think. So the gyro driver might have vulnerabilities in it, for example. So that's important to have a real physical device. And so that's why I built the Droid Army, right? And the Droid Army is it's nothing more than a whole bunch of Android devices, always on, plugged in, and queryable quickly. So I can do a quick demo. Sorry about the blowing again. So this, we'll run the script here. This scans the USB bus to see what devices are there. And we can do it the old-fashioned way, like if you actually didn't have the tools, then you can just run this, which is a little bit less friendly to look at, I think. But you run this, and then you can see one of the devices is misbehaving, and one of them is legitimately not plugged in. So that's why we see that. Let's see here. Sorry. Let's do get prop. So this command just quickly runs against all of the devices. It's a little bit long, so it wraps a bit, but this pulls one setting out of the Android system properties that shows you sort of the manufacturer, the model number, and the version of Android, whether or not it was compiled with the release keys, or whether it was compiled with debug keys, although I don't see any that are not release keys here. But this is just a quick demo, right? Like, you saw how quickly I was able to just query that from all the devices. So it's a really nice thing to have to quickly find information. We'll get more into that in a little bit here. So existing solutions. This work was inspired by APK, I don't even know how to say it, I guess app Kudo probably. So I saw at one point while I was working on this book, I saw them post a little blog that came up, and it was they showed this picture, whoops. They showed this picture, and you can see I was like, wow, I want one. I totally want one of those. So and you can even see their logo on the phones. That's pretty cool. But their focus is a little different than my focus. So there's reasons why I wasn't able to do this. Since also TestDroid and AppTwack have come out, so these are great platforms, but there's a problem with them. For the purpose of vulnerability research, it's a sort of a really tricky situation, right? Do you want to be hacking somebody else's devices? Is that something they would allow? Is that something they'd be friendly with? They say on their pages, they're like, we never root our devices. They're all stock and it's all kosher and everything. But if you're going to try to write an exploit for a kernel vulnerability or something, there's no two ways about it. You're at least going to crash their phones, and ideally you would be rooting their phone. And is that something they're okay with? Beyond that, sometimes there's physical proximity requirements. You're trying to write a kernel vulnerability exploit. Sometimes the machine will hang. You have to take out the battery. You don't really want to be calling them up or emailing them like, hey, I hung everything again, like all 300 of your devices. Sorry about that. So, is it okay to exfiltrate data? Are they like, that's kind of I guess a bad term to use, but is it okay? Are they okay with you kind of like pulling information off of the phones and sending it back to you, or do they want you to like kind of, just be a good little boy and not kind of try to pillage their little phones there? Also, it's OPSEC fail, right? If you're doing vulnerability research, zero-day discovery, you really don't want to like share that information with some other person who's going to be, I don't know if I don't really say about their business model, but these guys, they're focused on app testing, right? So that means they're inviting lots of people to come and run their apps on their phones constantly, right? Like all the time. So do you really want to like put some, new exploit you're working on all these phones that somebody else can take their app through and just pull all that stuff off? So the answer I had was just to build my own, and so I started to put it together. The original design was real simple. I just wanted to get a big-ass hub and plug in lots of stuff. At the time, I had only a couple devices. First thing I did, I bought the big-ass hub. It's called the Mondo Hub. And we'll show it. I'll show you here in a minute. But I want to take a little sidebar and give you some advice about buying devices. Out of the 53 that we saw there when I scanned, or well, 52, but that are showing up, I bought most of them on eBay. I think that eBay is a great source of these phones. There's also Craigslist and SwapHub, but I don't like those. There's a reason why it's red. People who sell their phones on there typically are people who are really attached to their phones, and so they're trying to get almost full price for something they were carrying around in their phone or carrying around in their pocket for a year or two, and so that tends to be not a great source of a good value. I got a bunch of devices just by asking around, which I'll ask all of you to donate if you have devices. Thank you. It turns out doing this talk, people don't want to give Android devices to me anymore. I'm not sure why, but I think they want to buy a big-ass hub or something. But eBay is great. You can look for devices that have a bad ESN. A lot of times people who are selling their phones on eBay, they have no idea what the fuck that means. Excuse my language. That to them could mean, all it really means to them is they can't activate the phone on any carrier. It could mean that the baseband has been bricked forever, or it could mean that that it's stolen and that the ESN is just blacklisted on the carrier's network. It might work on a different carrier. So they don't know what's going on with it. And for my purposes, I don't really care. I'm not trying to get these phones onto a network. I'm not trying to make any phone calls or anything. So this is really a good source. People tend to part with phones that can't be used to make phone calls very cheap, even though it's really like a small computer. Plenty you can do with it without making phone calls. So cracked screens are also a great one. The only requirement really for devices to do this sort of setup with is that the USB port works. The battery has to work, has to be able to charge, although the batteries stay charged all the time. They never really go down. But cracked screens are perfectly fine as long as the digitizer works. So that means like you can actually touch it and interact with it. There's some things where you get into like the recovery of Android or something where you have to flash a stock ROM or do something different. And a lot of times to do that stuff, it won't work without the touchscreen. So there are very few requirements though. I mean, it can be cracked, it can be busted, half the case can be missing. I've got a couple phones like where half the case is missing. I'm like, whatever, just plug it in, it's fine. Let's move on, it's taking too long here. So I want to thank all these people, and I would like to give them a round of applause, the people that donated devices. Some of these people just straight up gave them to me. A couple sold them rather cheaply. Google's on this list. They've donated some devices to the cluster. But these guys are all great, and they've really supported me in my research. I put Occupant first because they've totally bought some of the devices so I can do research on them as well. It's great. So here's the first picture. This is around September. We started writing the book, I think, in August 2012, something like that. We met at DEF CON or Black Hat, and that's when we had our first planning meeting. So shortly thereafter, I was like, oh, wait, I might need to start getting some of these things together. So there's the Mondo hub. And you can see there's a couple of little Android TV sticks. Those things have both since died, so I wouldn't recommend buying those. In fact, that white one, while I was at Black Hat, my wife texted me and she's like, what's going on? I hear this loud clicking noise from your office every so often. And I'm like, that cannot be good. These are solid state devices. There is no moving parts. And so it turns out I get home and I never heard the click myself, but she said, oh, I unplugged the white one because it was the one doing it. And I'm like, oh, thank you. So I'm glad the house didn't burn down. And so I got there, I took it apart, and I guess what was happening is that the clicking was actually a large spark that was happening from one terminal inside of the device to another one. When I opened it, it actually looked like there was water damage, but it wasn't water damage at all. It was like electricity damage from arcing. So yeah, that one's no longer plugged in. The other one's flash memory just randomly died. So don't get those. They're cheap, but you get what you pay for. So. And then the other devices, this is an old Droid 1, this is a Droid Incredible, I think, or no, I can't tell what it is from this picture. And then this one's a Droid Aris. I mean, these are just some old phones, like my wife's old phone, my old phone, stuff like that, second generation Android devices. As time went on, I got more devices. This is a Nexus 7 with a case, and then got another Droid 1 from someone that had a broken screen, so I got some experience taking screens off and putting them back on. That was fun. This Nexus, Galaxy Nexus there, and then these are a couple of dev boards. This one up here is the Panda board, and this one is the Origin board. So this is an Exynos development board, and this one is OMAP development board, so TI. So I kept going, right, buy some more. Got this hub. You can see I'm starting to get a lot of things connected here. You can see here I'm starting to get organized, and I got things kind of zip tied together. Just a few more devices here, and it just keeps going, right? I got more devices. Becomes an obsession at this point. I think half of these were bought on eBay. So I spent a lot of time trying to bid snipe at the last minute to get these super value prices. And it works out pretty well, but it's it's a time sink for sure. At one point, I thought, hey, I should really hire somebody to come here and just eBay for me. Like, please find phones and bid snipe them. Okay, thank you. So it's getting bigger. Oh, look, you can see my son up there on the tablet. Cool. And for the record, this monitor, I no longer have this monitor. I just moved. I put this in the street, and with a bunch of other things. All the other things were taken. That monitor stayed in the street. So even the garbage pickers don't want that monitor. I couldn't even find somewhere to donate it. They were like, Goodwill, no, we don't take those anymore, thank you. So disaster strikes at this point. And what happens is, like, I come home from some event or just, from being out or whatever, and half the devices are not showing up to the software, and like look at my kernel log in one window, and it's scrolling like mad barf messages about USB bus, this and that. I'm like, oh, geez, what's going on? So what happened was the Mondo Hub died, and what it turns out is that the Mondo Hub ships with a 4-amp power supply for a 28-port hub. A typical Android device or a typical USB device will run at about 500 milliamps on 5 volts. And 28 ports times 0.5, that's 14 amps it would need, and they ship you a 4-amp power supply. So it turns out to not be so good when you try to draw more than 4 amps through it for a long period of time. I think it was almost a year that I did that, and eventually it just barfed. The hub's kind of neat in that it has, like, you can see the lights, but there's also a row of buttons next to the light, so you can actually turn each port off and on individually with a hardware switch. But like, when it died, some of the ports wouldn't work no matter what, and some of them, wouldn't even light up anymore. I was like, this is not good. So afterwards, sort of had to scramble to figure out what to do, and so I got these hubs, these little ones. They're actually turned out to be pretty nice. At this point, I only had Android 4.0 and later devices plugged in. I was working on a kernel exploit for Android 4.0 and up, so I just focused only on the devices that I needed for that. These devices are older, and they weren't vulnerable to that bug, so they weren't plugged in anymore. But this ends up being a much better situation. And so what I did was, at this point, I said, well, I don't want this to happen again, right? I want to be smarter. I want to understand what I'm doing here, and I don't want to have another, hub fail massacre. I could say that maybe the hub failing was the reason why that other little USB Android TV stick might have fried itself, because it was around the same time. So maybe that's what happened, or maybe that stick fried the USB hub. I'm not sure, but whatever. I wanted to make sure that what I was doing from now on was going to be more scalable. So I wanted to kind of future-proof the research and know how could I grow this much larger. And so I started asking around on Twitter, and Osman, who's a great hardware guy, he's like, well, the most I've seen on a single IC is 7. And so I was like, well, that makes sense, because when you plug in the Mondo Hub, even though it's 28 ports, which is a multiple of 7, I might add, it shows up as like a cascaded hub, right? There's only 7 on each IC, so it's kind of like an IC hooked to an IC hooked to an IC, and then out to the ports. So he says to get to 127, you need 21 hub ICs. And I'm like, okay, I'm not going to build a board. It's like that's too much work. I can't do that. But I wanted to know, how do you get to the maximum 127? And some of the replies to this tweet were pretty funny too. They were like, so why would you want to do that? I'm like, okay. And some people are like, so do you want to be able to talk, or do you need just to charge them, right? And I'm like, obviously I need to talk to them. And then someone was like, well, if you just kind of fake it and you just send a bunch of registration messages, then it'll surely crash your machine. And I'm like, okay, whatever. So this is what I came up with 7 ports. This is like the most you can do on a single root hub. So you've got a hub, the root hub, which typically only has maybe 4 ports on it. But I only use 1. I want to leave the other ports open for USB sticks, or maybe a single device to focus on real quick. Going to 1 hub, and then basically you have all 7 ports of that hub filled with hubs. So this is what I have sort of right now, and we'll see that in a second. But this is the optimal thing. This is where you hit the max. And the downside to using this situation is that it's not an even multiple, and so you end up with more than 127 ports. But I haven't actually gotten to the point where I can plug that many in. I don't have that many devices yet. So the design was built off recommendations from Charlie Miller and Sergey Bratis and some others. Basically, this is the hub I recommend. One really nice thing about this hub is you can get a program called like hubcontrol.c or something, and you can actually like run it and tell individual ports to turn off and on in software. The Mondo hub, actually, you can run that same command against the Mondo hub, but the problem with the Mondo hub is when you tell it to turn off a port, it turns it off, but then it turns it right back on. So you don't have that. It's not actually really control, I wouldn't say at that point. It's just kind of like a suggestion. But these are good price hubs. They're $26. They're not bad at all. They're compact. I bought tons of micro USB cables. I recommend Monoprice for that. Monoprice is great for lots of cables and all your cable needs. Really, it's really cheap. I wish they would, maybe sponsor me or something, but whatever. So one quick note is a 6-foot cable. It's really nice to have because, as you can see from the picture, I have these devices on a table. Like I don't want to stand right next to the table, and there's not enough room on the table for a laptop or anything. So it's not really conducive to have short cords for all the devices. Sometimes you'll want to focus on a particular device. Say if you just got it, you want to root it first time, or if you're flashing it interactively, like with Windows software or something. Sometimes you're going to want a little bit longer cable so you can actually bring the device from the cluster over to where you're working. So right now, this is what it kind of looks like. I haven't updated. I actually just added another hub into one of these 7 hubs, so I'm getting closer to the setup. But this is what it sort of looks like right now. This supported about 49. That's why I added one more. So I had like 5 more devices. It's like, oh, they're just sitting here on the table. I should probably bust another hub out and start getting closer. But once I got everything set up from the design, got the hubs together, all the parts, what I found was this other issue, and it's basically these wall warts that come with these hubs. I don't know why they're so large. I guess cheaper maybe or something, but they clearly do not fit on a power strip next to each other. Yeah, so I had to come up with a new solution. I was like, well, this is great, but now how do I power them all? And so I started looking around, and what I found was on the Bitcoin forums, actually, there were some guys who have had this problem with the like USB ASIC miners. You can buy these little ones, and they had sort of the same problem. They're like, how do we power all these USB ASIC miners? And so I found this post. This guy was taking an ATX power supply and repurposing it to power these little. So actually, it wasn't the USB Bitcoin miners. I think it was the ones that are like sort of freestanding ones. And so he came up with this idea like, well, hey, you just use ATX power supply and kind of splice off the power. The only thing you really have to worry about is the 5-volt rail in the power supply. You're not really using any 12-volt or anything. So you want to make sure that the amperage on that power supply is sufficient for all the hubs and devices that are going to be below it. So what I did, I had a power supply sitting around. It was just an old 350 watt one, and nothing fancy, but it does 35 amps, so it's plenty. I bought some of these Molex connectors. I bought some pins. Bought some wired barrel connectors. The ring sleeve ones. Well, that's not right, but anyway. So these are the part numbers. Ordered and put it together. So here's the assembled cable. Like most of the work was done right here because this was already done. I just had to put the pins and everything in there, just for the 5-volt. And then I hooked it all up together. It looks something like this, just like sort of a big umbilical that's going to it. I mean, it's really nice because no more wall wart problem. The downside is I've got this power supply sitting on the floor. No big deal. But it really solved the problem, and everything is up and running as of this point. Then I ran into some a little bit more scale issues, right? Started thinking about more scale issues. Like how do I solve these other scale issues? Because this would scale okay to 127, but App Kudo says they have 360 something, right? If they have 360 something, then how do you get there, right? And so I started thinking about it, and what I want to do is kind of like put a small ARM box in the middle. It would be really nice because like right now, if I run VMware, the bottom sort of status bar shows all the phones in like this really long, because they show each USB device down there. And so that would be nice to not have to see that anymore and stuff. But I think this is a way to scale. I mean, otherwise you can add more USB root hubs with an external sort of PCI Express, additional root hub or additional bus master or whatever you want to call it. But still, like, that's going to run you out of PCI slots. So this is a much more scalable solution, I think. I haven't gotten there yet, but if I can get enough devices, then I'll get more motivated to do it. So also running out of physical space and batteries are becoming a problem. It turns out if you leave a phone plugged into a charger for a couple of years, it tends to not make the battery too happy, especially with certain models of phones. I know Larry mentioned Droid Bionic. Some of the older generations of Motorola devices in that time frame, like their batteries swell pretty quickly, actually, like around a year. I think they have some power leaking issues going on there. I'm not sure what's up. But a lot of them work fine. I want to try to power the phones without batteries, but that's obviously a problem for phones that you can't open, like without voiding the warranty and stuff. So these are just some thoughts. Right now, you've seen the table, and I'll show you some more pictures of the table kind of currently, and you'll see why a vertical solution might be a better thing. So here's like only 1 month later, right? This is after I put everything together. It kind of matches with these pictures here. So this is the line of hubs. This is the first hub, the one that all 7 hubs are plugged into, and then these are all the rest of the hubs. And it turns out, like, when I moved into my new house, I actually did this the other way, where the umbilical was in the back. And I found out that that's not really a good idea. Don't do it that way. Do it like this, because otherwise, all the ports, all the charging ports and stuff for the phones are all on the bottoms typically. And so you can't have the devices oriented so that you can actually walk right up to the table and just touch whatever device, if it's that way, without like making the cables bend all funny and stuff. So this works out actually a lot better. It was pretty disappointing because I put it all together and I was like, this kind of sucks. So I don't have to do it all again. So I had to take it all apart, put it all back together again, but now it's back like this. This is 2013 December. This is the 3.0, I call it. So 3.5 is kind of what it is right now. It's in the new house, and like I said, I put it all back together again. The one thing is that since it's a new house, I have a different layout in the office, so I had to switch it to the other side. But like, it works out really well. Like, the way it's laid out right now, I can literally walk right up to the table and touch whatever device is malfunctioning or like barfing, and that will happen if you have a bunch of these. Just yesterday, so this is all connected with one USB cord, so sometimes when I reboot or whatever, I just pull that one USB cord so that when it boots up, it doesn't see like, 10 or 15 different hard drives that are coming out of these guys, 'cause some of them export like an external drive interface. So I don't want them to clutter up my my hard drives list. And so when I plug it back in, the machine understandably gets a little pissy at me because it's like, oh, hey, here's 50 things right here. There you go. And so it takes a little bit of massaging when you do that to get it all up and running again. And then sometimes, like something will freak out. I don't know, like this device up here sometimes fights with this device, and they're like, oh, I'm this guy. No, I'm this guy. It's like, come on, guys. Like, just plug one into a different hub, and sometimes that helps. Sometimes I'm just, moving things around, but it's kind of like a living being. You kind of have to like feed it every now and then and discipline it sometimes. So yeah, so this is what it kind of looks like right now. Actually, I think I've added a few more devices since I took this picture. I have some. If you see me around the conference, you can see like Saturday. I haven't had a chance to. This isn't accurate here. It's not today, but pretty close. So only added like 5 more devices since then. So let's talk about the tools real quick. So no tools existed like this. We mentioned Kudo and the other guys. So they provide people with an API to their system, but it's kind of like the only thing that they've released source-wise or at all really to talk about what they've done is that clients for their API basically. So it's less useful for my purposes. Obviously, I can't run stuff on their cloud service, so I needed to put some tools together. The important features, I think, like number 1, managing devices by human-friendly names. And if we go back over here to this and we run the ADB devices again, like ADB supports out of the box telling it which one to talk to, but I can't imagine wanting to memorize all these, and I certainly don't want to type all those. Like, that's really, really, really ugly. And so like the way it is now, I can say well, this guy right here, that's the SGS3, for example, and then I could just say, I want to talk to the SGS3 right now. Much, much better. That's a huge, huge win in itself. What else? Like provisioning devices quickly. So getting a new device, you want to get it into the cluster and give it a human-friendly name. It's really important to just be able to do that quickly. There's a couple of other steps when you get a new device. In Linux, like by default, you don't have support, or you don't have access to every USB device that gets plugged in as a normal user. So you have to go and kind of tell the Ubuntu system or whatever you're running, you've got to go and tell it what the vendor ID and the device ID for the devices to tell it to give you access as a normal user. And that's not covered in the tools, but once you do that, you still have more to do, right? You have to scan for the devices to kind of see what's the new device that's suddenly there that's not in your list of things that you've named already. And so that helps. Handling transient devices is also cool. Like that's a nice feature because sometimes you might want to carry your phone around with you, but you also might want to plug it in to do some research at the same time. And if you want to do that, then it's nice to be able to kind of not have to try to send commands out to that device when it's not plugged in. That's kind of the big problem with that. Is if you do that, it'll just kind of hang or spit some nasty error message, which kind of clutters up your output. And the main goal of doing it is to just be able to run a command against all the devices at once. The tools are available free already. They're already on GitHub. Haven't made any changes recently, but there's probably some coming in the works here. Just haven't pushed them up yet. So the requirements are really only a Ruby interpreter and the ADB binary. My ADB binary has actually been patched to, and here's the patch down here. The only thing that the patch really does is it relies on Busybox to set the terminal size. I don't know if any of you have used ADB. How many have used ADB to shell into a device? That's pretty good. I'd say almost half. It's pretty good. So if you do that, though, let's say your terminal is humongous, like full screen terminal like I have open now. The Android device, they never thought to send that information down to the device. When you shell in, you're getting like an 80 by 24. And I don't think many people use 80 by 24 these days. But that's what the Android device just assumes that you're using when you shell in. So if you try to use VI or something, it's going to run it in a little portion of your terminal. If you're typing really long command lines, they wrap in a weird spot. And so that's really annoying, I find. So that's really all the patch does. It just takes your terminal settings from your local machine and tells the device, hey, this is the terminal size. It also changes the working directory. That's another annoying thing about shelling into an Android device. There's only one directory really that an ADB user can write to in the whole device. So why would you, shell in and get dumped into the root directory where you can't really do anything? So this one will change to that directory, data local temp. So the scripts just wrap ADB mostly. They take the user name, or the user supplied name that you've given to a device, and they translate that into the serial number, and then give that to the ADB binary. There's not a whole lot of rocket science there. The most sophisticated part of the scripts are probably doing the looping and sort of the output of it to make it so when you do run commands, you can get a much better sort of outputs. You can see here you got the device name on the left here, and then the little colon and then the stuff to just to condense the output. That's mostly the rocket science there. It's not great, but still it's simple, but still very elegant and powerful. So the tools are limited on Android devices, so I highly recommend getting a good Busybox binary. I recommend this one right here in particular. Sorek put this together. It supports SE Linux stuff in there. That's something that most Busybox binaries don't do. It's built against Bionic. A lot of Busybox binaries that are out there are built against UC libc, or they've got a static glibc linked into them. That makes not only the thing huge, but it also creates some quirks because of differences between those systems and Android. Although Android is based on Linux and has a Linux kernel, they treat the user IDs much differently. And they've properly put all that support into Bionic, so they still support the POSIX APIs, and they kind of give you the right information back from them. So linking against Bionic is kind of really important for the Busybox. The downside is that there's some older devices that this particular binary doesn't work on. So, I mean, on those devices, I just use an older one. It's no big deal. Yeah, so they don't have grep on a lot of phones. Like grep is kind of like one of those tools as a security researcher that you run a lot of times, limiting output and looking for individual key things in other files. So having Busybox is really indispensable. Supporting data. So at this point, I think I have something like 300 gigs of stock ROMs for these devices. I try to collect them all, but it's a little bit difficult having to look back into the past to try to find OTA updates for some phone that no one carries around anymore. But these are great for doing offline stuff as well as for flashing the devices back to stock, or even flashing the devices to different versions of the stock ROMs. You can also extract them, although that's kind of like a very special thing for each one. Anybody who's done any embedded or firmware research will understand what that's about. Each OEM uses their own sort of packing mechanism and stuff, so it's really problematic to try to do that in an automated way. It's one of the problems I'm looking to solve in it, but not in these tools, different tools. So they're good for extracting offsets from files or looking for ROP gadgets or just tons of stuff you can do offline. Even you can do lots of auditing offline. Just in case swears by having a stock ROM. Whenever there's a new device, you'll see him tweet like, "Hey, anybody got a firmware image of this guy?" Because he'll just start pulling it apart and looking for vulns, statically offline. It's totally a way to go. Not the way to go necessarily, but it's a way to go. You still have to have the device to test out what you think it's going to do anyway. So source code also, I think source code wise, there's tons of source code out there, mostly the Linux kernels. Some people release their modifications to the AOSP platform as well, although they're not required to. With the kernel, they are required to release the kernel. So if anybody has an Android device and you can't find the kernel source, then you can start raising a flag because they have to provide it by law. So I think at this point, source-wise, I think it's less than 100 gigs. So total, like 400 gigs of stuff to support that Droid Army. Surely it's not required to have all that stuff, but it can be quite helpful in a pinch. So there's more info on this sort of stuff, where you can get it, and where you can get source codes, where you can get binaries, both in this book and also in some of my other presentations from last year. So let's do some demos on the Droid Army. Let's see what else we can get out of this thing, right? Let's see let's see. We did the fingerprint. Let's do the kernel version. We didn't do that one. That one's fun. Oh, version. So, cut 60, is that going to work? Oh, we don't want to sort it, though. So I'm going to see what my terminal size is here. Oh, no. $85. I think we're fine with 60 then. Let's do 85. Can you guys see this in the back? Yes? Yeah? Okay. All right, this is going to take a while because it's going to query all the devices and then sort the output. So that's all the kernel versions of these devices sorted by kernel version right there. It's really nice to be able to pull that super quick, right? You can look. It's kind of funny too because this chronologically orders the devices in a way. These are the older ones, and then these are the newer ones. So that's one good example of something you can do quickly to figure out. System on chip wise, there's a directory in Android that you can look at. This directory here, dev block platform. If you look in there, there's usually like one folder, sometimes two folders. But you can see here, like this one is a Tegra device, so we know this is using an NVIDIA chipset. We know that this guy is using a Qualcomm chipset from MSM. So you can really start to see, similarities between devices. It's important to see those as well as the differences. The differences is where the vulnerabilities are going to be, but the similarities is where you're going to find places you can make the most impact for your research. So if you're going to look for a kernel vulnerability, you might want to focus on probably the Qualcomm kernel, given that there's so many Qualcomm devices, and maybe secondarily on Tegra or something. So this one here, the S3C, that's a Exynos chipset. So that's nice to do. We can query and see what privileges are we getting from, oh, that's not it. Space ID. Yeah. Oh, that one's gonna, we'll just check to see. So this will show, which devices are rooted and which ones are not. It's a little slow on some of the older devices. It's got to kind of fire up and query, like, the Android subsystem to ask the Super SU if it's allowed to execute as root or not. So clearly the Thunderbolt is not running with root, so let's root the Thunderbolt. What do we say? You guys want to do that? So the Thunderbolt is a write protect device, meaning you can't write to the system partition. And they call that S-on, and I don't like to turn that stuff off. I want to keep everything as stock as possible. So, oh, that's not going to do it. Let's see. It's a little weird on this tiny little keyboard. Maybe I'll use the real one. Oh, I don't even have it in this command history here. We're going to use impactor. And the --JDuck option, that's a special one. If you want that one, you have to ask Sorek. All it does is make it so you can run it on the command line without having the GUI. So usually impactor is like a GUI thing where you kind of select what you want to do. But I just asked them to put it, only to use the exploit only on the terminal, and then to do specifically to only do the thing where it spawns telnet D as system. And then let's see. Trying to remember where this one is. Cluster working. Yeah, let's do that one. Go. All right. So this one will just use another vulnerability to escalate privileges from system to root, and it seems to have failed, although it thinks it succeeded. That's interesting. Maybe the Thunderbolt's on its last legs, huh? So I won't bore you guys with too much of trying to mess with that device. Let's move on. So other tasks like auditing tasks, something that's great is you can quickly check for an existing driver node in the dev file system. This is really nice if you're say auditing some kernel source and you're like, well, here's a bug right here. Wonder if any or how many Android devices would be affected by said vulnerability. So you can quickly check that. Let's see. So we can look real quick which ones have this device, the PVR, SVR. I mean, that's really quick. And you can also see quickly the privileges. So like one of these, none of these do, but one of them, could potentially have it, but then not expose access to anything. It's a nice thing to know. See if any of them have Exynos mem. No, it's not called. Yeah, there we go. One does. Oh, when I rebooted the T-Bolt, it upset the whole system. Now we got half the things missing all of a sudden. Anyway, now they won't be queried. Now that I ran the reconfig script, they won't get queried anymore. We won't see any more of these. Oh no, device not found. So what else? You can use it to compare devices. You can quickly run basically a find on / and list all the devices and permissions and stuff for the whole device. You can compare that against the Nexus device. It'll help you find and pinpoint out where OEMs or others maybe have made changes to the code. That's a really handy thing to do. What else? The init scripts are great to compare against one another. There's the init scripts, since they do run as root and early in boot, they're often a source where vulnerabilities have been introduced. There was one of these vulnerabilities I just reported in the Black Phone a couple weeks ago. They just fixed it on Tuesday. So that wasn't an init script. So that was I found that by comparing init scripts against some other init scripts. Also, this file here. Whoops, wrong button. This file here, the etc. system permissions. This actually is something that OEMs tend to change quite a bit when they're building their phones. They'll end up with system apps, which are special apps that are baked into the ROM, and to support those, they'll actually add permissions into this file. So if you compare this file from any given retail device to like a Nexus device, or the stock platform.xml from the AOSP checkout, then you'll quickly see what new potentially interesting permissions might have been added. Sometimes there have been permissions sort of like backdoor permissions, where if you have them, then you can kind of do anything you want. So that's a good place to look. So what else? You can also install apps, of course. I haven't done a lot of focus with these tools and using them on app testing. There's been a little bit, but not a lot. It's actually really surprising how much you can do, how much you can automate using ADB. I think I have in here. Yeah, we'll get to the next one. So you can push and pull devices, push and pull files from all devices if you want to actually compare binaries to one another offline. The pulling files is a little bit interesting in that you can't just keep pulling the same file from every device and putting it in your current directory, because you'll just overwrite it over and over again. So it actually uses a directory structure that's based on the names of the devices. So it'll pull them all into subdirectories, and each one will actually kind of represent the root directory of the device. So you can say, for example, like pull the libwebcore.so or something on all the devices, and it'll put it all into directories for each device, and it'll be inside that, or it'll be like system lib, webcore, just like it will be on the device. Which is cool, because then you can do like chroot stuff, maybe use some QEMU on the binaries to run them offline if you can get that together and stuff. Also good for debugging. You need those binaries like the libc and some other things if you want to do any sort of remote debugging on these guys. So you can also test exploits, and one example I have here is this 6282 vulnerability. This is the one that I was working on actually when, oh, you're going to be a butthead, huh? I thought. So there we go. So this pushes that binary onto all the devices really quickly. You can see how much time this saves. You don't have to type like ADB push device all constantly. It's really, really not fun. And then we can quickly execute that as well. Yeah, there we go. So this exploit actually, like, it works whether or not you have so the vuln is 4.0 and above, right? 4.0 up until, I think it was patched in 4.4, so it's like 4.0, 4.1, and 4.2 and 4.3. But after 4.2, I think they added a mitigation. They put a mitigation in place where you were no longer able to read the kernel symbols. And so this exploit works regardless of whether you can read the kernel symbols. The vulnerability is really sad and funny. And that what happened was, somewhere along the way, someone changed the ARM kernel in Linux, and they forgot to do some testing, I guess, because when they made this change, they removed the checking for whether or not addresses you were writing to were in kernel space or in user space anymore. So you could just write or read from any kernel memory address, and they didn't realize that this was in place for many years. But the sad thing was, it was in the upstream code for a long time, and it was fixed in the upstream code in a long time. They actually fixed the vulnerability long before I think it even reached Android devices, but Android devices are developed with such older kernels, and they take much longer to get them in there. So like the vulnerability was hanging around, but it didn't really affect anything for a long time. And then eventually they backported it, of course. This vulnerability was found being used in a Chinese root tool, and so Qualcomm guys were like, yeah, we're not going to have that bug sitting around anymore. So you can see it worked on some of the devices, and when I was trying to run it before, I came up with this command line here, and this one actually will like only run it on the devices that are affected. So it's nice to be able to group them. You can see you can group the devices by commas. I got like on my to-do to actually create proper groups, so you can actually say like, run it on 4.0 and later, or run it on all Qualcomm devices or something like that. But it would require, a little bit of manual work to actually get those groups put together, I think. So you can also do the subset interaction, and that's kind of what that's a demo of. I didn't run the exploit again because we already ran it before, but you know, the idea would be instead of seeing all these names with nothing there, you'd see just nothing but UID 0. So the exploit worked on those guys. The exploit, all it does right now is it prints out the user ID and GID. It didn't print the static string UID equals 0 and GID equals 0, so it's not Hollywood stuff there. All right, so a final demo. We can run arbitrary scripts on these guys too, which is pretty powerful. I thought I had it set up here. Not checkout master. What's going on here? Let's go here. Oh no, we don't want that one. We can push it again. How am I doing on time, actually? We're out of time? I think we are out of time. Well, I'm going to skip this one. So we're low on time. I want to leave some time for questions. Other tasks, you can send intents, do fuzzing. Done some of both these things. It's really useful to do. Fuzzing on a heterogeneous cluster is a little bit different than fuzzing on a homogeneous one. So you might find that even with the same input, it might crash some device but not other ones. Totally seen that a bunch of times. I used this cluster also to check some compatibility for Patch Droid, the project that Colin and John Overhide did. It's been useful for that. Also, there's this big vulnerability called the Add JavaScript Interface vulnerability. It was discovered by a bunch of people, but I think the first people to really make a big stink of it were the MWR guys, so props to them for making a big stink. But this bug is hilarious. What happens with this vulnerability is you can actually embed any given web page, if you visit it with a vulnerable Android device, can inject with JavaScript shell commands, right? So you can just download a binary and run it from remote completely. And it's not like memory corruption. It's totally supported or something. But they've since tried to fix this, but it still remains to this day to be a big issue because of the way that they decided to fix it. The reason I put it in here is actually used this cluster to test all the devices that I had to see what was vulnerable and what was not. It was very revealing. I wrote a blog post that's on droidsec.org if you want to check it out. I won't go too much into it, but it actually showed me that some OEMs had backported the patch for it, but at the same time, and these are from some older devices, they backported the patch, but at the same time they had a separate variable. It's exposed through a global variable in the JavaScript namespace. So some of them added their own global variable thing, and that was vulnerable, even though they patched the original one that was found to be vulnerable. So in conclusion, things I learned, there's obviously various problems with having lots of USB devices plugged together. And you can see I ran the ADB reboot on one, and then all of a sudden, 3 or 4 of them disappeared for a while. They may or may not come back. We can go check real quick. I'm actually curious. Did you guys come back? They did. They came back. Yay. Sorry. So that's fun. Never. It really is like having a child because you never get bored with this. It's always something interesting happening. Random distractions are always fun. You're sitting there, you hear beep 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 beep. You're like, what? Which one of them you did that? If one of them rang, thank God the screen comes on when it rings, because, oof. Yeah, if not, then I wouldn't have any idea. If one of them rang, though, I would probably crap myself, because they're all in airplane mode. If one of them's ringing, that's not good. So, again, I mentioned the batteries earlier. I won't go into that too much more. So the future directions, I want to continue to get more devices. I'll plead for you to donate, although I understand if you don't want to at this point. It's kind of a self-defeating talk in a way, asking for donations after showing you what fun things you can do with Android devices. But further automation, I want to add, so there's a couple of tools I created and released, one called PrivMap and one called CanHasAccess. PrivMap is useful because Android is a very privilege separated operating system. There's a lot of things that happen when they happen, something has to talk to something else, has to talk to something else. Certain processes run and they have access to certain pieces of hardware, but the browser itself doesn't. And the browser may need to do something with that hardware, so it has to kind of delegate that to the other thing. So PrivMap shows kind of processes and what their users and groups are, and kind of that helps you to figure out if you need a particular privilege, like who can I get it from? Like, I need access to the audio group. How can I get access to the audio group? Who has it? That'll give you a place, where to look for a path to what you need. Can has access is really just a glorified optimization of like find / -perm, whatever. A lot of people will run that a bunch of times, but can has access is a single binary you run. It'll actually give you prioritized output of what the permissions are that are weak on the system. So if there's like a setuid binary, it's like, hey, alert, setuid binary, like right up the top, which is a lot more serious than, say, a world writable directory maybe, although that's pretty important as well. So it gives you that. And one note on that, it's like you really need to root your Android devices if you're going to do this kind of auditing. You're really not going to get very far if you try to just use an ADB shell user. Like the /data directory is a very important directory in Android. It's like the only writable place. And it's also set permission-wise so that you can't really look in there without having root. So device diffing is another thing I want to do. I want to automate some more of the diffing of things. So just kind of make it easier. You just run something, get a report, instead of having to kind of do it all manually each time. Automated firmware switching would be super sweet. Like, hey, I want to run this binary on all revisions of, let's say the Nexus 4 stock ROMs, like all the way from the first ROM that was released with all the way up to the current one. It's totally doable. The question is like if I'll get to it. And another thing I want to do is in my to-do list is try to sort of automate provisioning, right? Like every time you flash a ROM on a device, you've got to like go through the setup and put in your name and connect to your Wi-Fi. It's really irritating. So I want to get rid of all that and to automate that. So I'm also open to suggestions. It is sort of an open, not sort of, it is an open source project. So if anyone wants to contribute, by all means. In conclusion, devices that are different from each other, like in the Android ecosystem, they really complicate security testing and research. The more devices they build, the more devices that need to be tested. And I don't think that people are doing a great job of doing that. Otherwise, we wouldn't see a lot of the vulns that we do see out there for the Android guys. I mentioned the black phone before. That actually shipped from the factory with a system app, which means it ran with system privileges that was debuggable, which means you can attach a debugger to it. So you could literally just attach to it and say, hey, do this. And that was like, system is almost root on Android. It's not root, but it's almost root. System owns the /data directory. So it's pretty important. But that's embarrassing, right? Like, why didn't somebody check to see that? So anyway, but no other devices were affected by that because it's that unique thing that's going on, right? So building an army like this, it really helps you scale your research. You can do things much more quickly, testing against multiple devices at once. And this actually is a great point, and it goes beyond Android. This is not just for Android. If you have, for example, like Hoshin has, probably a bunch of AVs set up at once. You could just kind of fire one file at all the AVs and see what happens, right? That's much more fun than, I'm going to install this AV and try it, and then install this AV and try it. So it applies to everything. It applies, to Windows as well. You want to have all the versions of Windows because things change over the years. How does it change? All that stuff. So it applies more broadly. It's definitely worth the investment. I think all in all, I've spent probably a total of $10,000, which I guess is a lot of money. But most of the devices were not expensive. I think the most expensive device is probably around $600. And I've only bought a few that were like that. Many of them I bought were like $300 or $400. And then the ones from eBay were like 50 bucks. Come on. Like, that's awesome. And then the ones people give you, it's like, yes, free is great. Free like in hugs, right? So recommendations, definitely use the hardware design. Like, don't make the same mistake I did. The Mondo Hub looks cool, but it's probably not your best bet. Ask around for a device you want to build one of these. Follow the device buying guidelines. Definitely great to eBay and BidSnipe, although don't BidSnipe against me. I'm just kidding. So use and contribute to the tools, and by all means, join DroidSec if you're interested in Android research. And let's give this book away. So usually what I say is whoever has the best question, but you have the best question. Oh, you have the microphone. Okay, I was like, what? Okay. So yeah, I mean, if anyone has any questions, by all means, raise your hand, and I guess he has the microphone, he'll bring it to you. And this could be yours. It's well worth the however much money it costs. I think it's like $50 or $40 or something.
Did you do any prototyping with the ADB over IP interface?
I have used the TCP, ADB over wireless, yeah. But the problem, so I have all these phones in airplane mode, right? So they're not connected to any network whatsoever, so it's a little bit difficult to use that. But there's definitely cases where I've had to use that, like kernel debugging on some of these Samsung devices requires that you use this little dongle thing that talks to the USB port. And at that point, obviously, you can't ADB in at the same time because your USB port's taken up by something else. For that, and for those, I've definitely used the TCP over, ADB over TCP IP. That's also a great point too, because I think ADB over TCP IP is kind of the goal. If I get to the point where I have to scale it and have a machine in the middle, like the goal will probably be to use that protocol in the middle there to kind of bring everything together. It'd also be nice because then my VMware won't have like 50 little icons in the status bar anymore.
We have time for one question.
Sure. So if we only ask one question, it's real easy for him to get the book.
Hi. So instead of like donating devices, have you considering setting up some kind of a cloud setup? Maybe other people can actually attach their devices to your cloud, and you can just debug them or do whatever. I know that, for example, if you do like vulnerability research, that's probably not a good idea. But at least if you do just general purpose research, like finding files, taking stuff out of the device, that might actually be a viable option, and also massively scalable.
What's the last thing you said?
Huh?
What's the last thing you said?
Scalable,
Yeah, okay, yeah. I mean, yeah, I've definitely considered it. And these other solutions exist for that purpose. But like, and on that note too, I'm happy to run commands if anybody is interested in my devices or in a quick query or survey of what I've got. I'm happy to run commands. I've done it lots of times. I had some guy doing some kernel auditing. He's like, hey, how many of your devices have this driver? I'm like, run a command. I'm like, none, sorry. It's really disappointing to be auditing and finding a bug and then not have anything affected. But yeah.
Actually, I meant like other people connecting to your network.
No, nobody's connecting to, they're not connected to any network really.
No, but for example, if I have a bunch of devices, instead of sending it over and dealing with all the USB stuff, maybe over TCP, you might be able to, I might be able to actually hook them up to your stuff, to your setup.
Yeah, that's possible. Yeah, I know what you mean. Okay, yeah. Yeah, okay, I've considered that, definitely. I get the question now, yeah. It's just tricky though, right? Like if I'm developing like some exploit for some unknown vulnerability, I don't want to share it with everyone who's got devices, right? But for some stuff, for sure. Yeah, definitely. There's a couple of really cool projects out there too. Vlad 902, he did a project recently called the Android Census or something like that, where he pulled a lot of information off of a lot of devices. I think 300 something devices. And then he's made that data and the tools available where you can quickly look through a dump of sort of like the find slash with showing all of the files and directory structure with permissions and stuff. So he's done some of that, and it's pretty cool. So some of it you can just do it once, right, and you're done. You don't have to keep it online. But for testing exploits, for sure, you need to have it online. So do we want to do any more? We're done. He's like, get out of here. Okay, bye. All right, thank you, everybody. I don't have anything else, just bonus slides.